Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which converts an arbitrary binary tree to a tree that holds children's sum property. First, let us take an example. As you can see in this example, we increment the values in the nodes to make them satisfy the children's sum property. Now, let us have a look at the algorithm which will assist us in this. Let us also have a sample tree to test our algorithm. We pass the root node which is 50 to function convert tree. So, node will point to 50. We take three variables, left data to store the left child of root, right data to store the right child of root, and diff to store the difference. We check if node is null or if it is a leaf node. Since neither of them is true, we go to the else part. Now we recursively call for the left and right subtrees. So first we pass the left child of 50, which is 7, to function convert tree using a call stack. So node will point to 7 and left data and right data will be 0. Again, we check if node is pointing to null or if it is a leaf node. Since neither of them is true, we call for the left child of 7. The left child of 7 is 3, so now node will point to 3. Since node 3 is a leaf node, as it does not have any child, we return to the call stack. We resume execution for node 7 and now pass the right child of 7, which is 5. Since 5 is a leaf node, we return to the call stack. We continue execution for node 7. Next, we check if node's left is not null. Since 7's left is not null, we assign 7's left to left data. So, left data will be equal to 3 for node 7. Also, since right child of 7 is not null, right data will be equal to 5. Next, we get difference of nodes data and children's sum. So, diff will be equal to 5 plus 3 minus 7, which is equal to 1. Since diff is greater than 0, we make node data to node data plus diff. Hence, we replace 7 by 7 plus 1, which is equal to 8. Next, execution for node 7 is finished. We resume execution for node 50. Now, we pass the right child of 50, which is 2, to function convert tree. So, node will point to 2. Since 2 is not null and it is not a leaf node as well, we pass the left child of 2, which is 1. So, node will point to 1. As 1 does not have any child, it is a leaf node and we return to the call stack. We resume execution for node 2 and now pass the right child of 2, which is 30. Hence, node will point to 30. Since 30 is a leaf node, we return to the call stack. Now left child of 2 is 1, so variable left data will be equal to 1. Also, right child of 2 is 30, so right data will be equal to 30. We compute the difference of nodes data and children's sum. So, diff will be equal to 1 plus 30 minus 2, which is equal to 29. Since diff is greater than 0, we replace node with node plus diff. So, 2 will be replaced by 31. Execution for node 2 is over. We resume execution for node 50. The left child of 50 is 8. So, left data will be equal to 8. Also, right child of 50 is 31. Hence, right data will be equal to 31. We compute the difference, which will be equal to 31 plus 8 minus 50, that is minus 11. Since diff is less than 0, we call the increment function with node and minus diff. So, in the increment function, node will point to 50 and diff will be equal to 11. Now, in the increment function, we check if left child is not null. As it is true, we make nodes left child equal to nodes left child plus diff. Hence, the left child of 50 will be 8 plus 11, which is equal to 19. Next, we recursively call the left descendants. So, node will point to 19. Since 19's left is not null, we update 19's left to 19's left plus diff. Hence, we update 3 to 3 plus 11, which is equal to 14. Again, we call for the left child of 19. So, node will point to 14. Since 14's left and right child are both null, the if condition is not satisfied. And we finish execution for function increment. Also, we finish execution for node 50 in convert tree function. We have the final tree which has been converted to a tree that holds children's sum property. Now, let us have a look at the time complexity of the program. This code will run in big O of n square complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.